All right, so in the polygons unit, there are really four basic topics. First of all, there's just a few definitions, so I want to cover that. But the major topic is the interior angle theorem. And then the next topic is the exterior angle theorem. And then you have your area formulas, so your square, rectangle, triangles, and trapezoids. And then the circumference and area of circles. So I'm actually going to do a video on each one of these four. So we'll break it down that way. So let me kind of go right to the at a glance notes, and you can take a look at this. Let's see if I can make it a little bigger. All right, so first of all, let me just explain some of this vocabulary. So a polygon is convex if no line that contains the sides of the polygon passes through the interior of the polygon, and it is convex. If it is not convex, then it's called concave. I kind of think of it as this. Concave means that it caves in. So if you take a look at this one here, it kind of caves in over here and it caves in over here. Over here, there's nothing that's kind of caving in, going to the inside of the polygon. Everything is kind of clearly on the outside. So this one here would be concave and this one here would be convex. A polygon is equilateral. So equilateral means its sides. So lateral meaning its sides. So if all the sides are congruent, then we said that it is equilateral. So for instance, a square has all sides are congruent, so a square is equilateral. An equilateral triangle is a triangle that has all three sides the same length. A polygon is equiangular if all the angles are congruent. And they say the interior angles, which means the angles on the inside of the polygon. So for instance, if you think of a hexagon, I can't draw an octagon very well, right? If all these sides are the same, then all these angles would actually also have to be the same. So this would be both equiangular and equilateral. And when it is both equiangular and equilateral, then we say that it is regular. So if it's a regular polygon, all the angles are congruent and all the sides are congruent. So for instance, a square is an example of a regular polygon because all the sides of a square are congruent and all the angles are congruent. All right, so here you have examples of a regular polygon. This is kind of like the one I drew, but this one's prettier. So you can see all the angles are congruent and all the sides are congruent. So this is in fact regular. B, well, all the angles are congruent because it's a rectangle, but not all the sides are congruent. The opposite sides are congruent. This is congruent to this, but they're not all the same. So for instance, this might measure 3 inches, but this might measure 5 inches. So they're not all the same. So this one is not regular. And then we have this interior angle theorem. So what this is this gives you a way to figure out what the sum of all the interior angles add up to. So for instance, I could figure out what all these angles would add up to. And the formula looks like this. N minus 2, where n is the number of sides, times 180. So if we take a look at an example, let me erase this. And it says here that gives you a polygon. It doesn't have to be a regular polygon for you to use this formula. Any old polygon will do. It has to be convex, not concave. But we're only dealing with convex polygons, so you don't even really have to worry about concave, except for the fact that they exist. That's all you really need to know. So the interior sum formula tells you if I added this angle plus this angle plus this angle plus this angle plus this angle, all 5 of those angles, it would tell me what that adds up to. Well, our formula is the sum of the angles equals n minus 2 times 180. That's my formula. So anytime it says find the sum of the interior angles, this is the formula that you would use. Well, n is the number of sides. So all I have to do is go to this here and count. Well, I've got 1, 2, 3, 4, 5 sides. So in this case, n equals 5. I'm just going to plug that into my formula so that I know the sum of the interior angles is going to equal 5 minus 2 times 180, which would be 3 times 180, which would be 540 degrees. So now I know if I added each one of these angles up together, it would all add up to a total of 540 degrees. But in this example, it said find the measurement of angle A. Well, I know B is 96, I know C is 83, I know D is 135, and E isn't listed, but it gives me that little symbol, so that little symbol means that it's 90 degrees. So I know 4 of the 5. So I could add up all of those 4, subtract it from my 540, and then I would have A. So let's go ahead and add those all up. Take out my calculator, see if you can see this. Yep. So 96 plus 83 plus 135 plus 90, that's a total of 404. So I know the total sum is 540. I'm going to subtract 404, and I get 136 degrees. So I know that this angle A has to be 136 degrees, because that way if I add them all up, they'll equal the 540. If you have any questions on that, please let me know.